What is going on, guys? Welcome to your 16th physics tutorial, and in this lesson I want to talk to you guys about circular motion and something called centripetal force. Sounds pretty sweet, huh? Oh, it is. So I could just go ahead and give you guys the definitions, but what fun would that be? I want to draw something. So let me go ahead and draw this dude right here. I'm going to name him Bucky because that's a really cool name. And what this dude is doing is he is holding onto a string and he tied a baseball on the end of that string. Why did he do this? I have no idea. Bucky's a little bit weird, but not only did he tie a baseball onto a string, but he is whipping this thing around in a circle as fast as he can. Why he's doing this? Like I said, I don't know. He's a little bit weird. But anyways, this example helps us to study circular motion in something called centripetal force. So this baseball, we're going to just call it the object because, well, they call things objects in physics. Now, whenever you have an object and it's moving in a circle, the force between the object, which is the baseball, and the center of the circle, which is where he's holding onto the string, the force between these 2 points is called the centripetal force. So in this example, the string, let me draw my arrow a little bit better, the string would represent the centripetal force, the force between the object and the center of the circle. So just remember that because that's probably going to be on your test, or, I don't know why you guys are studying physics, but that's a term that you need to know, centripetal force. So another thing I want to tell you guys is something that's probably going to blow your mind. This is one of those weird physics facts that I'm about to tell you. And guys, don't blame me because this is kind of confusing. Blame Newton because he's the one who thought up all this crap. It's this. If Bucky is standing here in the same location and he is whipping this ball around at a constant speed, remember that, I said that, constant speed, Newton says that this ball is accelerating. Okay, let's take a break here for a second. You're telling me that if this ball was traveling around the circle at a constant speed, then it's still accelerating? What the heck is going on? That's like the opposite of acceleration. Well, let's go ahead and take a look at the formula for acceleration. Acceleration, as we know, is change in velocity over change in time. Now, up until this point, we studied things moving, pretty much dropping a ball from a building, or if you were in a car and you went from 0 to 60, then that car would be accelerating. So, even though this ball isn't changing speed, why did Newton say that this ball was accelerating? Well, let's go ahead and take a closer look at this formula for acceleration. It says change in velocity over change in time. Now, as we know, velocity is made up of two things, speed and direction. I don't know if I'm going to have enough space, so I just write dir. So velocity is pretty much speed and direction. So before, we were just concentrating on speed, and typically whenever you think of acceleration, you think of things changing speed, but the truth is velocity can also deal with direction. So even though this ball right here isn't changing speed, it's changing direction. So that's a weird physics fact that you guys have to remember. Objects can well, excuse me. I need to take a deep breath because I guess my brain is getting confused and it's confusing my tongue as well. But objects can accelerate even when the speed is constant because the formula for acceleration, which includes velocity, includes direction as well. So even though the speed is constant, it is indeed changing direction, which therefore changes the velocity, which causes this ball to accelerate at a constant speed. So go ahead and tell your physics or science teacher that things are able to accelerate at a constant speed, and after their brain blows up, you can move on to the next tutorial. So thank you guys for watching. Don't forget to subscribe, and I'll see you guys in the next lesson.